begin with this one. One of the most difficult things on these problems to me is after you read it is trying to figure out your right triangle diagram. So what this one is saying, let me just read this. It says a surveyor's measuring a distance across a lake, and he's done these basic two things. He set up a transit. A transit is just something that measures angles. That's an angle measuring device, so that's what he's doing, okay, with that. And let's see, it says that's on one side of the lake, and that's 140 feet from a piling. That's just something that he's set up so that he can measure the distance from the transit, which is measuring an angle, and the piling on the ground. A lot of times it's pretty easy to measure out a distance on the ground, so that's what he's doing. Okay, then it says from the transit, the angle between the piling and the pier is 55 degrees. Okay, so I think I've read that right. So here's what I want you to kind of draw. Okay, I have to think about this for a minute. So we have a lake. Okay, what we're trying to do ultimately on this is it says the piling, this is the key thing, the piling is directly across a pier on the other side of the lake. So let's just say that you have a pier down here somewhere, and then this is the piling like this. So what you're doing is you're trying to measure that distance across the lake. So the question on here is, what is the distance between the piling and the pier for the nearest foot? So that's what we have there. Now we're at a stage where we're still working with right triangles. We're not ready to do law of sines, law of cosines, and that kind of stuff yet in the class. So what we have here is the transit is over here somewhere. So the transit's on the same side of the lake. And what he's doing is he's measuring that distance off like that. And what that is that distance is 140 feet. So that's what the problem is saying, is you're measuring the distance from the piling to the pier. He's measured off on the ground 140 feet on the same side, because that's what that says. And then it says he measures the angle to the pier to be 55 degrees, okay? So that's what that angle right there is that, okay? So I mean, that's kind of the way that's worded is kind of weird to me, but what it's saying is the transit, he set up his transit and the piling on the same side of the lake, measured that off, and then we're going to use this to find that distance from there to there. And a transit's just an angle measuring device. You look through, and it'll measure angles for you. Okay. So what we're trying to do is we're trying to find this side right here. Okay. Why does it keep doing that? Oh, I got my pen upside down. That would explain that. Okay. All right. So that would be side X like that. All right. So what we have is we're just dealing with right triangle trigonometry. So we've really turned this problem into a right triangle where you have 140, 55 degrees, and X like that. That's all you know on the problem. And of course, you have to assume that's a right angle because you have to at this stage. Okay. So let's look and see kind of what we have here. Look at the angle that we're looking at. What is this? That's side what? Opposite. What's that? Adjacent. So that side is opposite. That's adjacent. Which trig function relates opposite over adjacent? Tangent. Okay. So that means what we're going to do on the problem then is we're going to do this. What's wrong with this thing? Okay. So what we're going to do is we're going to do the tangent of 55 degrees. That's the opposite X over the adjacent 140 like that. Now we can solve that equation for X and we got the answer to the problem. So what would you do to get X by itself? Multiply by 140 is probably the best thing to do. That clears the fraction. Then you go directly to your calculator. So what we need to do on this is in degree mode on our calculator. Now my calculator's disappeared. Okay, so you just want to make sure that you're in degree mode when you do that then. So you just do 140 times the tangent of 55, and then that should give the distance across the lake. At this stage in this section, we're still dealing with right triangle trigonometry. We're not doing what we call oblique triangles, where we don't have 90-degree angles yet. Okay, so that's the idea. Okay, so if you do that, and if this thing would load up, everything's kind of messing up here on me tonight here. Okay, has anybody done that on their calculator yet?
199.94.
Okay, 199 point, here it comes. Okay, 199.84, is that what you said?
94.
Okay, right? Okay. Okay, all right, so let me just make sure I've got it, because I need this calculator for other things I'm going to show you tonight anyway. So let's see what we got here. Okay, so let's see, degree mode. I need to make sure I'm in degree mode. Okay, and then I can put in the result, and when we got the answer to the problem. So we have 140, and then we have the tangent of 55, and then we'll just round that to the nearest foot, so we'll just say 200. Okay, that's like 199.9 for all practical purposes. We'll just round that off to 200 feet like that, and that gives the answer to the problem. Okay, all right, does that make sense to everybody once I get the triangle set up? Okay, hard part's getting the diagram set up, and once you do get your right triangle, it should be pretty easy to do that. Okay, so 200 would be the right answer to that problem. All right, okay, next thing, let's see, we did example 5. So let's see, I'm going to go to, this would be page 4, we're going to talk about bearing. We haven't talked about this yet. This is used a lot in navigation, and it relates well to trigonometry. So first thing I want to show you is from this diagram what a bearing is. So if we were looking at bearing A, this just is a way to write this distance right here. So whenever you do a bearing, you're always measuring the angle from the y-axis. Okay, so this is saying that you have an angle that's 70 degrees towards the east, and then you're going to the north. So what you do when you do bearing is you do this first. You do the north-south first. So if you're doing this bearing, you would say north, then you would say 70 degrees, and that 70 degrees is veering to the east, so that's how you write that bearing. And what you're always looking at is this angle between the y-axis and this. Okay, that's the idea. It's north and south first, east and west next. Does that make sense? Okay, that's how bearing goes. That's how you're writing that out. Okay, now if we go to B, okay, let's see, B is down here. Okay, so what are we doing? We first start with what? We're going south. Okay, then that angle between the y-axis is 35 degrees, and then we're veering towards the east. So that would be south 35 degrees east, right? Everybody understand that okay? Okay, that's the first thing you got to understand with bearing is how these things are measured. Okay, C, let's see, how would that go based on the diagram? South, 15 degrees west. Good. Okay, so you start with south, then you go 15 degrees west like that. Okay, and finally, how would D go? North 80 west. Good. Okay, good. So you're going to say north, and then you're veering 80 degrees to the west like that. Okay, does that make sense to everybody? Okay, so what you got to do on that is you're always looking at your angle as measured from the y-axis. That's the idea, okay? All right, now down in this diagram below here, there's a little bit more to do on this, but you'll see some of this in your homework. It's pretty simple to just find these bearings. So what you're doing is you're finding the bearing from O to A. So you're really looking at this piece right here, okay? We're going to find that bearing. Well, what's different about this problem is I didn't give you the right angle. I gave you this angle. So what would that angle right there just be in your head if that's 75? 15. That'd be 15, wouldn't it? Okay? Because they make a 90-degree angle, so that would be a 15-degree angle. So the answer on this bearing would be north, 15 degrees, and then you're veering to the west. Okay? So you got to figure out that angle. Okay? If you're going to do the bearing from O to B, then you're looking at this bearing right here. And you can do this in your head. That angle right here is 30 degrees. So what's the bearing?
So it's north 30 degrees west.
There you go. North 30 degrees. Okay, and then you're veering to the west like that. So just make sure that you have the right angle. In this case, you had enough information to figure that out.
I'm confused. Why is it north 15 west?
What's that?
Why is it north 15 west instead of east?
Are you talking about the one I just did?
No, A. There's O to A.
Oh, that would be east. Okay, yeah, thank you. Because you're veering to the east. I apologize. Okay, so that would be that bearing like that. All right, is everybody comfortable with what I mean by bearing and how you measure it then? Because we're going to do a couple of word problems that have to do with bearing, and it really boils down to how well you understand this and how well you can put together your angles. Okay, so on this problem, what I'm going to do with this problem right here is we're going to try to first of all draw a diagram. That to me is the hardest part of the problem, is just drawing the diagram. So what this one says is you have a forest ranger that's at lookout A, and he sights a fire that's directly north of her position. So what I'm going to do on this is I'm just going to put lookout A there, and I'm going to go straight up north, and that would be where our fire is. Okay, so we got a fire that's directly north like that. Okay, right, and what we're going to try to do on this, ultimately we're going to try to look for a right triangle when we do this problem. So that's what we got there so far. Okay, then if you read on, it says another ranger at lookout B, which is directly west of A, sights the same fire. Okay, so basically what you have is lookout B is to the west, so that's this way somewhere. So that's lookout B, and see we're kind of making a triangle as we go, and that distance is 2 kilometers like that. Okay, then what we want to do is what it says is it says it has a bearing of north 41.2 degrees east. So what I'm going to do on this is I'm going to go straight up like that, and then I'm going to veer over to the fire like this. And the whole key to this problem is to know where that 41.2 goes. So does that 41.2 go here, or does it go there? Top one or bottom one? Top one, right, because you're always looking at, you can think of that as like a y-axis. So you're north, veering east that distance like that. So that angle right here, this one is what would be the, what's wrong with this thing? This would be 41.2 degrees east like that, okay? So that would be what your angle is. Now, what we're doing on this is it says the question on the problem is how far is the fire from lookout A? So ultimately what you're doing on this problem is you're finding that distance there, so I'll call that X, okay? So really what you can do on here is a real simple thing. You can see your right triangle. What you ultimately need to do is just figure out this angle there. How do you find that angle that I highlighted in yellow? You just do 90 degrees minus 41.2, right? And if you do that, that will give you what this angle is, and that's what we need, is we need that angle in the triangle, so that's going to be 48.8 degrees like that. Now what we have is we have a right triangle that we can use to use the basic trigonometry on. So that's all we got to do. And again, what you want to look at this is in relation to that angle, what do you have? Opposite, adjacent, so again, what are you going to use? Going to use tangent again, right? Okay, so that's what you would ultimately do. Once you get the diagram, try to find a right triangle on that problem. So now we would say tangent of 48.8 degrees is equal to opposite x over adjacent 2. Okay, then we can multiply both sides by 2. And what that would end up giving me is that would give x is equal to 2 tangent 48.8. And we need to make sure we're in degree mode and calculate that. And then we got what we need to find on the problem. Okay, so that's going to be 2 and this one just said round to 2 decimals. So we'll say 2.28 kilometers is what our answer is. And that looks like a pretty logical answer to me, because that side's 2. This side right here is probably going to be a little bit bigger, because this angle here is going to be smaller than that angle. So that's a logical answer. Okay? All right, does that make sense what I did on that problem? Okay? All right, so the key thing is understanding that that bearing gave that angle, so you had to find that angle in order to work with your triangle. Okay? Any questions on that? Are we okay with what I did? Okay, all right. The next one is kind of a little bit harder. It's got a little bit more going on in it. So this one right here, what I want to do here is read the problem. Let's see if we can get a diagram drawn on this one then. Okay, so this one's a little bit tricky, I think. Okay, so as I read this, the first thing I have is it says you have a sailboat that leaves a port south 72 degrees west. Okay, that's going to be a piece of information when we start drawing this. Then it says after sailing for 2 hours at 12 knots. If you're not familiar with knots, knots is a rate. That's called a nautical mile. And then what's going to happen is the boat is going to turn 90 degrees towards the south. And let's just kind of pause there and see if we can put together what we have so far. Okay, so what I'm going to do is let's just put a little dot there, and let's call that the port. Okay, that's where the ship is going from. So if you look at what I highlighted in yellow, that means that the sailboat is going south 72 degrees west. So what I'm going to do is I'm going to kind of use some dashed lines on some of that. So that's courses directly south. And then we're going to veer 72 degrees to the west like this. Okay, so what we're going to do is kind of move over this direction, something kind of like that. All right, and we'll just kind of stop at that point. And then that angle right here, this whole entire angle right there, I want to kind of write this out because we're going to end up with kind of a messy diagram here, I think. So that whole angle right there is 72 degrees, all right? And then this side right here, the information on this part is that you sailed for 2 hours and then you had a rate of 12 knots like that. So that's what I got so far in the problem, all right? Going south, 72 degrees west like that. So that's what I get so far. Okay, now let's go on to this part right here. Now it says the boat is going to turn 90 degrees towards the south, okay? So what that's saying, towards the south, course, is that way. That's going to be at a 90-degree angle. So we're going to get a right triangle. You're not going straight south. You're going towards the south at a 90-degree angle. So the way I'm reading this is like this. Okay, this is just going to go straight down for a while. You're going to have a right angle right there. And then it says 3 hours, okay, at a different rate. So we just go down like this, and I'm going to write a note to myself that that is 3 hours at 9 knots like that. Okay, so that's what we got so far. All right, now what we need to do on this is ultimately the question on this problem is what is the bearing to the ship from the port? Okay, so this is kind of where I think you can get a little bit tricky. So if you were measuring this bearing to the ship from the port, you would be looking at an angle in there. So what I want you to do is let's just draw a line that connects these two things like that. Okay? Now, you're trying to give the bearing on this. So that angle right there is the bearing, right? You can tell you're going to get as an answer probably south, that degree, whatever it is, west, correct? Okay, so that's ultimately what we're looking for is that angle right there. So I'm going to put a little note to myself that that is the angle that I'll call that angle alpha or just some variable like that. Okay? So what we end up having on this then is we got to somehow figure out what that angle is based on the information in the problem. So first of all, we know that distance is equal to rate times time. We need to know the length of the sides of this triangle right here. So if you go here, you would have this distance, and you just go rate, 12 knots. And don't worry about the units. They're going to work out fine on this. So we've got 12 knots times 2 hours. So we're just going to say that distance is 24. Okay? All right, so that's just some distance. I don't even remember what the nautical miles actual units are in that. But it's okay. That just gives us an answer, and then we're going to be consistent. On the next one, we have distance is 3 hours, or 9 knots, okay, times 3 hours, like that. So that's going to give 27. So what we're getting in here is we're getting a right triangle in here that we can try to deal with here. All right, so here's kind of the way I look at this problem is kind of like this then. All right, so if you look at this right triangle right there, that's the main right triangle right there. Let's see if we have enough information to figure out some stuff, okay? Perhaps we could figure out this angle right there. We might be able to figure that out okay. And if we did that, we could also figure that angle out if we needed to as well. So that would be one approach, is to figure out that angle right there. And if we can figure that angle out, then how do you figure that angle out? It's 72 minus that would give the rest, right? Okay, that would be kind of the idea. Does that make sense? Okay, so let's just kind of look at this right triangle and see what we can do. I'm just going to draw the right triangle kind of at the side here because this is ultimately what we got to work with. Okay, so I'm going to call this that angle like X or something. We have 24, we have 27. Okay, so we need to find X. We have enough information. If you talk it out, you have opposite over adjacent again. So again, you're going to use the tangent. So you're going to say tangent of that angle X is opposite 27 over 24, and then we can use our calculator to find that. Now, what do you need to do on your calculator to find x? You got to do the inverse tangent, right? So you got to do inverse tangent of 27 over 24. Anytime we're doing an angle, we need to work with the inverse trig function. Okay, so I'm going to take my calculator and go inverse tangent of 27 over 24. Okay, and when I do that, I'm going to have an angle that's approximately, let's just use one decimal, 48.4 degrees like that. Okay, so that means that that angle right there is 48.4. And then we got all the information we need to do to solve the problem then. So what we do to get the final answer is we just do alpha is equal to the big angle 72 minus the 48.4 that we got. And if we do that, I think that'll give 23.6, I think is what that is. I had worked this out before class. Let's see, so I'll make sure that's right. Okay, so that's 23.6 degrees. Okay, now what we need to do is need to write the bearing. Okay, so if we do the bearing, so it goes like this. So if this angle right here is 23.6, and again we're looking at this angle here, how are you going to name that bearing? South, 23.6, west. There you go, that's the answer to the problem. Okay, so that would be south, 23.6 degrees. West would be your bearing like that, okay? And this is used a lot in navigation. So it's kind of, we like to just kind of show the idea in the trig class what bearing is, okay? But ultimately everything you do still boils down to the right triangle trig. You just got to know what bearing is, okay? Does that make sense to everybody? So if you're clear on what the angles mean in bearing, you should be fine as long as you can get a good diagram drawn, okay? That one's kind of a tricky diagram. So is there any questions on anything? Okay, everybody feel pretty good? Okay, I sure can't tell. All right, give me a sign or something. Go ahead.
Should it? What's no, I don't know the name of the thing, so I couldn't describe it properly. But yeah.
Are you having trouble with how I wrote the answer, or?
No, what's the code? What's for the angle? The one angle we didn't find.
Right, like this angle right here.
Yeah, that.
Yeah, you really don't need to find it.
Yeah.
But if you did, you would just do 90 minus 48.4 to find that.
Isn't that supposed to be the same as what alpha was?
This one, no.
Okay.
Because they have to be. I think what you're thinking is when you have parallel lines, like if this was 23.6, so is this.
Okay. Yeah,
but they're not parallel lines.
Okay.
Okay, because that line right there is not parallel to that. But I know that's what you're thinking.
Gotcha. Okay.
Okay, very good.
I was thinking the same thing.
Yeah, and I can see how you could think that, but it's not the same.
Okay.
Okay, because they're not parallel lines. Okay. Okay, I'm going to do just a little bit with the harmonic motion on this, but I do want to kind of get into a lot of the 5.1 tonight because there's a lot of proving identity. So I want to just kind of introduce you to the basic ideas here tonight. Okay, so we've already learned about trig graphs and functions. So basically, if you have an object that's moving on an axis, simple harmonic motion just means it's periodic. Okay, so it's doing a very similar pattern. An example of that might be like springs. Okay, where the motion goes up and down, kind of oscillates in a manner where it's going through similar points over and over again. Okay, so what we have is the motion is going to have an amplitude of A. We learned this kind of stuff in your trig functions. So in simple harmonic motion, we write this. So we can either have D is equal to A cosine omega t, or the other thing would be D is equal to A sine of omega t, like that. Okay. Now what this is the maximum displacement is going to be the amplitude right here. So that value right there, that A, is just the maximum displacement. Now you pretty much already know that from your graphs, hopefully. So remember, the cosine wave went like this, right? And that amplitude gave a maximum value, didn't it? And it also gave a minimum value, because on these problems we're not looking at any vertical translation like up or down. So that thing right there, that amplitude, is going to give you the maximum displacement the object did from rest. Okay, so what would happen is, I'll give you an example, and we'll talk about this a little bit probably on Thursday night. If you have a spring and you have a weight from it, okay, the rest position, what you could do on that, the equilibrium position is when it comes to rest. Well, if you stretched that spring, what would happen? It would just kind of go up and down like that, so that A represents the maximum distance from rest. So if you stretched this thing out, the weight would go there, then it would just kind of wiggle back and forth until it got back to equilibrium. So actually that thing can be represented, that motion can be represented by a sine or cosine wave. Okay, you'll learn a little bit about this in a physics class. Okay, we already know the period, because we learned that already. So the period is just equal to 2 pi over omega. Okay, that's something that we learned when we were doing graphing. And omega is going to be some positive number. And the period gives the time it takes for the motion to go through one complete cycle. You already know that's what a period is. 5 key points, 1, 2, 3, 4, 5 on a sine or cosine. So what this is given is the amount of time it takes to go through that one complete cycle. Okay? The frequency is just given by, you can think of this if you want, this is something that's probably worth writing down. The frequency is just this. It's just 1 over the period. It's the reciprocal of the period. So notice instead of 2 pi over omega, it's omega over 2 pi. Okay? Oh, I got it right there. I didn't even see that. Okay? So that's what the frequency is it's the reciprocal of the period. Okay? So I want to just kind of introduce you to the basic ideas tonight on here. So I want to just go down to doing these two problems here, then I'm going to stop this, then I'm going to go ahead and start you with 5.1 so I can get most of that done tonight. So with this says that you have an object. This is like a spring. It's pulled down in a negative direction from the rest position, then released. We're going to write an equation for the distance of the object from its rest position after t seconds. Now you can do either a sine or cosine. It doesn't make any difference. So I'm just going to do on here d equals a sine omega t like that. Okay, so I'm going to go ahead and do that. So what's going to happen on this is, okay, basically what you have is the amplitude is going to be 9, so that goes like this. Okay, then the period is going to be equal to 3 seconds. Okay, like that. Now, that does not give you what omega is. Okay, so what you have is you have the formula. The period is equal to 2 pi over omega. So you got to solve this equation. So what you're going to do is you're going to replace the period with 3 seconds. So that's just going to be 3 is equal to 2 pi over omega. Then you can solve that proportion. You can cross multiply that and find what omega is. So that's going to be 3 omega is equal to 2 pi. Then divide by 3. So you get omega is equal to 2 pi over 3 like that. Okay, so what's going to go in for that omega is going to be 2 pi over 3. So what you're doing is you're getting a trig function that's modeling the behavior of that spring. So what you'd have as a final answer, you'd have the distance d is 9 sine of omega, or 2 pi over 3 times t like that. Okay, so that's what you would get for a function if you're modeling that with a sine wave. Okay, so we've actually looked at that enough that that shouldn't be anything that's brand new to you. Okay, now that's as far as I'm going to go tonight on this section. Your 4.8 is still due next week, next Tuesday. So I can get into 5.1 and try to get through most of the proofs and stuff tonight. I want to go ahead and shut this down and then go ahead and get into the handout.